Today I'm just going to talk about implementing ParFlow with JUBE, so using JUBE as a flexible development, benchmarking and run control framework. And so what is JUBE? JUBE is a benchmarking environment where you can configure, compile and run a benchmark suite on several different platforms, and it provides a script-based framework to easily create benchmark sets and run those sets in different computer systems via XML scripts. It also provides some result verification and analysis. So the benchmark data is written out in a certain format that enables the benchmarker to deduct the desired information easily. And without a benchmarking environment or without using something like JUBE, all these steps have to be performed by hand. And another reason to use it is that it's being actively developed at JSC by Thomas and Sebastian. So this is just an example workflow, again using the XML script. So the analyze, verify, execute, prepare, compile, platform XML all go into the benchmark XML, which gets run by a script. The output get put in certain run lots from 0 to 1 to however many times you run it. And then you can couple it with a result analyzer and that looks at certain patterns, which I'll explain a bit later on in the talk. So just some general features of JUBE. You can create a suite of tests using the comma punctuation mark. So for a given parameter, for example, if you've got a parameter number and you want to run a certain suite with this variable 1, 2, 4, you put a comma between them and it runs 3 tests. Scripting parameters, you can create a parameter which is based on the value of another parameter in, say, Python mode, for example. And general features, you can load files, you can use substitution, you can control environment variables, use shared operations, set parameters, incorporate scripts, and many, many more things. So the use case that I'm going to talk about today is with ParFlow, which is an integrated parallel watershed model. It's fully coupled dynamic 2D and 3D hydrological groundwater and land surface processes. And what I mean by that, if we look at the water cycle, it deals with surface runoff, infiltration, groundwater discharge, groundwater storage, and gets forced by offline meteorological forcing files. So as you can see here, you've got a variably saturated infiltration front on the figure on my right, and that gradually sinks through the porous media to the water table. So actually running ParFlow is quite complex because you've got a land surface model coupled with the subsurface model. So you've got pre-processing, so static field files such as topography files, the subsurface files, land surface model files such as a land sea mask file, and these all go into the TCL script. So you pre-process these beforehand and they get put into the tool command language script. And then the output from the ParFlow model is, at the moment, binary files, netcdf4 files are coming. So you might want to post-process and have diagnostic output files or just netcdf files. So trying to combine all those factors from pre-processing to the post-processing and archiving, we thought of a kind of template base and custom script model. So the orange boxes are directories and the green boxes are XML files. And so in the templates, you've got the ParFlow model templates. You might have the Euro Cortex domain, you might have an Alpine domain or whatever domain you're looking at. Then you've got platform related templates. So if you're running it on supercomputer in Jülich versus supercomputer in Munich, for example. pre-processed and post-processed templates, and then profiler-related templates. So all the different profiling tools that you can instrument your code with can be loaded up. And then in your custom script, you've got your specific model and job settings that you set there, and these flow into the base run control directory. So you can either run a benchmark with profiling, or just straight run control with pre and post processing. So the whole chain. And so this is why we've kind of taken a modular approach to that. So in the actual base scripts, or the run control scripts, we've separated them out into 3 steps for simplicity: the compilation step of the code, the job submit step, and then the analysis step. So basically from this flowchart, you've got the compilation step, and if it does not compile, then errors out, and the submit and run step only gets submitted if the compile step was completed. Then after the job submission, the analysis step can be run at any time during the job. So when the job's running, you might want to do an analysis of the job interdependencies if you've got a chain job script, or you might want to do a bit of post-processing at the end, looking at the traces that you've collected and trace analysis, for example. So going into the actual XML script here, the setup compile, you've got your custom job stuff at the top, which gets substituted out via JUBE with your custom script. And then you've got your templates, and these are the profiling templates that you instrument your code with, and then your various build scripts that you use due to those profiling tools. In the next step, you've got your run job step, and this builds the job submission script and database with model parameters set from the custom XML script, and prepares the monthly, weekly, or daily external forcing files, the initial condition files, and the static field files. And so again, you've got your custom job stuff that gets substituted out at the beginning, and then your templates at the end of your different ParFlow model setups, like Europe or the Alpine region. And then at the end, you've got your submit script, which could be a chain job script or any job script that you choose. And then you've got a profiler post-process step, or indeed a general post-process step if you need it. And then the analysis step, you've got a result pattern that's user-defined in your custom script, and then you can set the table out into this format, so task per node, nodes, and the process results. So say you're looking at timing, for example, or memory. So this is the direct output from running the various models: Euro Cortex domain, Alpine domain, and idealized model. This 12-kilometre water column and the 3-kilometre Alpine surface runoff is post-processed diagnostic variables and netcdf. And here we've got a silo pressure file from running the idealized case as an example. So this takes care of everything from pre-processing to post-processing, so it makes it very easy. Before this, we were using a series of user-defined scripts, which is not very robust. And going into now the profiling options using JUBE. So these are just a few of the ones we've got: Scorpy, Scalaska, Lineate, Darshan, X-Ray, Vector Advise, and Paravar. And some examples of output. So we're looking at efficiency on new queen, weak scaling, looking at the load imbalance and cube after we've collected traces. And this is a Darshan IO report, for example. So everything's automated for the user and they don't have to worry about build script parameters and things like that. So another thing that we added based on the Echo code diary is the performance metrics extraction, which is automated via JUBE, which Thomas and Ilya helped out with. And these are the various compilation modes. So according to the different code diary performance metrics parameters, and so you can either just run all at once or you can run them separately, and then it builds a table. This is just an example of the table that's produced. So the user can see what was run, how long it took, and then the general P2P calls, for example, etc., etc. This is going to change, I think. So this might need to be updated, but it's a really valuable thing to put in your code. So in summary, JUBE can be used for run control and benchmarking and profiling and code instrumentation. It can also be used for result analysis and post-processing. And we're planning to use JUBE as a test harness for regression and unit testing, possibly with continuous integration. And all the above leads to a more efficient allocation of resources and better strategic solutions for software improvement, because it's very easy now to run benchmarks and see where the bottlenecks are with different profiling tools. So what's planned for the future? We've got a integrated terrestrial modelling and data simulation from the subsurface into the atmosphere model. And so this is quite complicated, and we're thinking this would be a good thing to use JUBE for to run. However, to be able to take advantage of using JUBE, I think there probably needs to be a couple more things integrated in JUBE, such as allowing for job schedule failure and things like that, but hopefully those developments will be coming. So thank you very much for listening, guys.